Okay, so in this video, we're going to look at inverse Laplace with using the table. So in the last video, for example, we took this first function here. This was our first example. And we found f of s using an improper integral, right? The definition of Laplace transformations. Now we're given this nice table that we can use instead, right? We can use this nice table to do it instead. Sometimes to me, it feels like cheating. But our professor allowed it, but he still required us to know the definition of Laplace transformations. It was still on our exam, you know. But anyways, we can use this to find the inverse Laplace transformation. So inverse Laplace just requires a lot of algebraic manipulation. And it can be very challenging if you're not... Once you get the pattern down, though, it's easy. For me, when I first did this stuff, I remember I had the hardest time. I remember I took a whole night, just sat there, and I got nothing. It all just seemed like magic to me. But now, it makes sense to me, and I hope that I can help you guys make sense of it as well. So I have the table here, but I have it over here as well because I'm gonna need it this whole time. I was already trying this problem before. Let me erase that. Okay. This one, they give us the f of s, right? This is like what we would have solved for. It wants the inverse Laplace. It wants f of t. We want f of t. So, we need to take the inverse Laplace of f of s. In this case, 3 over s squared plus 4. Now, to do this, we're going to look at our table. And for this first one, it starts off really weird already. You think they would give you a nice simple one, but no, this one already is weird. If you look at it, which ones are in the form that we want here? Let's look. Well, probably one of these four right here, right? Because we have that s squared on the bottom. So probably one of these four. So now that we narrowed it down, let's look at it. We have 3 over s squared plus 4. 4 is an even number. I mean, it's plus, so that narrows it down even more. Which one is it? Sine or cosine? Well, you see that in this case, the a is even. The s can't be odd. You can't take an ab squared on the bottom. So you have to use, in this case, sine. You have to do sine for this one. So what you would do, and this is very weird, like I said, but once you get the pattern, you'll get used to it. Take out the 3 and just write it like this. And for this one, the algebraic trick that you're going to use is you're going to multiply the top and the bottom by 2. And in doing so, you can pull out that other 2 on the bottom, and you're left with this. Now that 4 can be rewritten in terms of a, like this. So the way that I like to think about it, this is right, I forgot. This is how I like to think about it. Not everyone's me, though. I like to write it out like this first. And then I see, okay, I need a 2 on the top. Right? So I just multiply both the top and bottom by 2. Pull that out. Right? That's a 2, not a z. Now we have this. Now we can go ahead and use our formula here. So we have sine of AT. A is 2, so we have 3 over 2 times sine of 2t. And that's the answer. So this is A. This is A. Oops. So that's that. It's not too bad. It's just that trick of multiplying top and bottom by 2 that you might have to get used to. Okay, now let's look at the second problem. We have 4 over s minus 1 cubed. So what could that be? Let's look at our table. I have it over here. What has... I see which one it is. So it can't be this one. Can't be any of these. Can't be this one because it actually be... But look at this one. I think I see something. Right? I think it could be this one. So with this one in mind, let's look at this one now. So, so in this case, our A is 1, S is S, n plus 1. So 2 factorial is 4, correct? 2 factorial is 4 because, how do you do factorial again? It's 2 times 2, yeah, 2 times 2 times, yeah, okay. Remember, 2 factorial is equal to 2 times 1, which is 4, right? So then this can be rewritten as 2 factorial over s minus 1 cubed. Or we can rewrite it as 2 plus 1. This one's not too bad, actually. So we know that n is 2, and n is 2, and our a would be 1. So this one's pretty simple, actually. We have t to the n, which is 2, and e to the at. What was our a again? 1. So it's just t. So if you want to be fancy about it, you'd write if your professor's a stickler for notation, that is. Tell you right now, mine definitely was. Equal to yeah, t squared e to the t. Okay. Number 3. Let's look at this one now. So by the looks of it, I can already see it's going to be, I think it's going to be one of these two. I think it's going to be the first one, though. Actually, it might not be. It could be this one. Yes, it could be. Well, let's figure it out. I'm actually not sure which one this would be. I'm not sure. It could be even something even more simple. Let's look. Ooh, I know. Can the bottom be factored out? Can that be factored out? I think it can, right? This can be rewritten as s minus 1, s plus 4. Let me think about that. Yep. S minus 1, s minus 4, s plus 4. And then guess what? When we have a situation like this now, we have to use partial fraction decomp. All right, this is one of our Calc 2 methods of integration. So much fun. Actually enjoy partial fraction decomp. Okay, let's see here. Now, for these problems, I'm going to do partial fraction decomp the long method, not the shortcut, because the long method is so much faster, in my opinion. Once you get used to it, so much faster. Anyways, partial fraction decomp. See if I remember how to do this. That would be what? A over s minus 1 plus b over s plus 4. And then you do the multiplication thing. Yeah. This would be a times s plus 4 plus b times s minus 1. You should already be familiar with partial fraction decomp after Calc 2. All right. Where was I? Now you could do the shortcut method pretty easily for this one, but like I said, I'm a long method enjoyer. So I'm going to write this all out. Equate like terms. We have 2 equals 4a. Oh wait, we have 2 equals 4a minus b. And we have 0 equals as plus bs. So we have our systems of equations here. A equals negative b, right? From this one. Cancel out the s's. If a equals negative b, then 2 is equal to 4, negative 4b minus b. So 2, negative 2/5 is equal to b. That's not very nice, is it? If that's b, then a would be 2/5. And I need another page. Okay. Now we would rewrite this, so that's, what was it, 2 over s minus 1 times s plus 4. That would be a over s minus 1, so 2/5 over s minus 1 plus minus 2/5 over s plus 4. That's an s. This is a 5. So I don't get this mixed up. Now, let's take a look. Now remember, for your FFS, you can have, in addition, right? You can have, remember, when we have multiple, what are they called? Subintervals. You can have integrals adding on to each other. So this is one of those situations, actually. If you look, I can already see which one it is. This one over here. This basic one over here, it's just e to the at. So for this first one, our a would be 1. So we have 2/5 e to the t minus 2/5. This is our f of t, by the way. Oh, come on. Why isn't it? Oh, that's why I said the edge. A with this case would be -4. I think. Yes, that's correct. That's our f of t. So that was not too bad. It's partial fraction decomp. Next one. I think we looked at one like this before. This one, for some reason, is screaming this one. I don't know why. Can it be? I think so. Yeah, it has to be that one. So let's take a look at this one now. Can we factor at the bottom? So, yes, we can't perfectly factor it out, right? But guess what? We can use, we can complete the square. Let's see if I remember how to complete the square. So I'm going to take out the denominator. Oh god. How do you complete the square? You take what? You take half of the second term, square it, and you're going to add on the second term squared. You're going to subtract the 5 over and add it on this as well to this side. That's right. I think that's how that works. Could I be wrong though? I should have this in my notes. It's been a while since I completed the square. Half of the first one. Oh, then you square that. Oh, you square the. Oh, okay. So this is what you do for you complete the square. You take half of the second one, half of the second one, square it over here, and you also add it to the other side after when you subtract the 5 over. So now we're left with squared plus 1. That would be minus 4. So plus. Oh wait. No, I'm doing it wrong. You keep this first term, then you add half of it squared to both sides, and then you do this as yes, of course. Then you can add the 4 over. We completed the square. Now let's rewrite this. S squared plus 2s plus 5. Oh, my bad. S plus 2 squared plus 4. Now, this can be rewritten as 2 squared, right? So yeah, it's definitely looking like it is this one. So I think we're still not done yet, right? We have to take out a 2. So S plus 1. Oh, wait a minute. I completed the square wrong. This 1 goes here. Sorry, my bad. Yeah. Yep. Okay. Yeah. That would make a lot of sense because I was confused for a second. Now that's, yeah, so that's nice. Take out a 2. Look at that. We have our A's that match now. And our B would be 2. So A is 1 and our B is 2. Oh, wait a minute. A is negative 1. B is 2. Yeah, so now our f of t would be e to the negative t cosine of 2t. Oh, I forgot. Don't forget the 2 that we pulled out. Yeah, so that's our f of t. Right, not too bad. Well, it's not too bad. I mean, I guess it's just kind of doing these over and over again, getting used to it. Next one, number 5. 2s minus 3 over s squared minus 4. I'm not sure which one this would be. But what I do know It's probably sine or cosine because of the s squared. Yeah, because of the s squared, I'd imagine it would be sine or cosine. But that's my guess for now. Or it could be one of these. You never know. What could we do to simplify this? If I take out we could make this 2 squared, right? We can do the same thing we did for that other problem. We can go like this. We can this is what I'm gonna do. This is what I'm gonna do. I'm gonna do this. 2. I think 2. Let's separate these. 'Cause I think this might be more than one thing by the looks of it. Yes. Look at the second one here. This is okay. Yeah. So we're looking at hyperbolic sine or hyperbolic cosine because of the minus. This first one would be what's already done. We have the s. That's hyperbolic cosine. This one here would be hyperbolic sine because we can multiply both sides by 2, right? Pull out the 3. Pull out the 3, multiply both by 2, right? This would be 2 times, my professor would say cosh of a, which would be 2t, right? Minus 3 halves 2 over s squared minus, what am I doing? Sinh, as he would say. Is it at? Yes. A, which is 2, again, t. Let me just check that. Yep, that's it. Okay, we have 2 questions left. Not too bad. Oh boy. This might not be. Oh, okay. This looks like it would be. Oh yeah, this is partial fraction decomp. No, is it? No. Wait. Oh, this is weird. I see an s squared, but there's an extra s on the bottom. Let me look. Let's look. I mean, we could okay, now this one's hard. I'm not gonna lie, this one is hard. This one is tricky. Can we get an s squared plus 4 on the top? Yeah, this is definitely, let me see if I, oh no, wait, we can use partial fraction decomp. Yeah, let's just use partial fraction decomp for this one. I don't see why not. I don't think we can do anything else. I don't know why I was second guessing myself so much on that one. Yeah. Let's do partial fraction decomp. I see now what to do. This would be what, a over s plus bs plus c over s squared plus yeah. Now I remember. That's what you would do for this one. And then this would be 8s squared minus 4s plus 12 is equal to as squared plus 4a. I went ahead and distributed myself, plus bs squared plus cs. Right? I went ahead and distributed in my head. Should be familiar with partial fraction decomp by now anyways. That is Calc 2. Equate like terms. 8s squared is equal to as squared plus bs squared. Negative 4s is equal to cs. 12 is equal to 4a. A is equal to 3. C is equal to... I don't know why that's S shouldn't be there. C is equal to negative 4. A is 3. 8 minus 3 is 5. So B is 5. Okay. Um, 3 over S plus, this definitely is what we should have did. 5s plus minus 4 over s squared plus 4. So we have a 1 over s situation. So that's just 1. So that's just 3, because it's 3 times 1, plus 5s minus 4 over s squared plus 4. Oh, we have to split that one up. So this would be pull out the 5. No, let me not do that. I can divide. Oh, I see what to do. You can is that an S or a 5? Wait. This is a 5 right here. That's an S, yeah. That's an S. Okay. You can pull out the 4, multiply the top and bottom by 2. Yes. There we go. So then, let me add a page. Our f of t, 3 over s plus 5 times s over s squared. Well, this would be 3, right? Plus 5 times the s's. So it would be, it's a plus. So it would be cosine. So an a is 4. So cosine of 4t, no, cosine of 2t. This would be 2 squared. Minus 4 halves times the 2, so we have the same a, so sine minus 4 over 2 is 2, first of all. That'd be what? Sine a is 2t. Not too bad. That's the last one. Oh, we have one more. Is that correct, though? Let me check. Yep, that's right. Okay, we have one more. Oh, yes. Is this one of those? Yeah, this is one of these. This one really got me. I remember. This is the one that really got me 1 year ago when I was in this class. This is the one that really got me. This is the weirdest thing ever. Let me see. Number 7. 1 minus 2s. Can the bottom be factored? Can it be factored? 5 minus 1 is 4, but that's not. That would be negative 5. No, it can't be. So you have to complete the square for the bottom there. So that would be plus 2 squared is equal to negative 5 plus 2 squared. That's s plus 2 squared is equal to, so plus 1. Yeah. And then that would be 1 minus 2s over s plus 2 squared plus 1. So this is where it gets weird. If you look at our possibilities here, it can either be one of these two. And wait, it's plus. Okay, it doesn't matter. We have an s on the top, so it has to be this EAT cosine BT one. It has to be this one. But you see here, we need s minus a, and we got to get that 2 out. So we can do this. We can split it up. So we are going to be using both of these, actually. Right? So wait a minute. Oh, wait a minute. The s minus, oh yes, this is the weird part. The s minus a's have to match. Forget about this. We need an s plus 2 on the top. Okay? We need an s plus 2 on the top. So what can we do to get that? Well, we know that 5 minus 4 is equal to 1. Right? So now you can group these two together. Yeah, you can look. You can do this. You can pull out the negative. And you can already see exactly what I did. But isn't that crazy? Like, I was losing my mind over this. I remember that night. That was a rough night for me. What is this? No. 5 minus. But now we have this s plus 2. S plus 2. Isn't that amazing? So now I can do this. This one's already done, but this one over here is not because the b's have to match. What can we do? Oh man, what can we do to get the b's to match? Oh no, you can just pull out the 5. Yeah, you can just pull out the 5. So then that's 5 times b in this case would be 1. A would be 2, negative 2. No, yeah, negative 2. So this one would be this one first. A is negative 2. So 5e to the negative 2t. Sine of b of t, b was 1, so t. Minus 2 times 2, so a negative 2, so e to the negative 2t. Cosine, there'll just be t as well, because b is just 1 again. Technically, I should put the squares on those. Technically, if I want to follow the table there. Okay. Let me double check that. 5e negative 2 sine t. Negative 2e negative 3. Beautiful. That's the answer. Okay. So this is inverse Laplace. And of course, we're going to get more practice with this in the next video, in the next section, when we look at the initial value problems. Right? So I will see you in that video.